Section 6.1b, geometric means. Our goal is to use geometric means to solve problems. So what is a geometric mean? Geometric mean is a proportion in which you have a pair of values that are the same, called the means. So these blue values here, these x's are called the means. So this is a special proportion. So it's a special proportion with the means equivalent. And again, the means are the x's. And when we go about solving this, you're going to multiply and you get that x squared equals the product of AB. Or your book goes as far as to say that x equals the square root of AB. My suggestion is to start with the proportion, because sometimes they'll say this is the geometric mean of. Sometimes they say, 9 is the geometric mean of 3 and what number. Sometimes they say, what is the geometric mean of 3 and this number. I find it easier just to start with the proportion. This first example says, what is the geometric mean of 4 and 9? So what we are going to do is I always start with the proportion and go, do I have the geometric mean? It says, what is the geometric mean? No, that's what I'm solving for. So I'll plug those x's in, and it does not matter where I plug in 4 and 9, and then I'll cross multiply. X squared equals 36. Square root both sides, and I get x equals 6. So what is the geometric mean of 4 and 9? It is in fact 6. Also brought up in this section is simplifying radicals. To simplify a radical is to break down a radical into the products of perfect squares. I strongly suggest copying this onto, like, say, the cover of your notebook or a note card or somewhere that you can reference the squares. So take a moment, copy this table down. I'm doing every other color so that it's a little easier to see. But there are your perfect squares. So x and x squared through 14. You should know through 15 on your own. So when we are using these, for example, we're breaking down the square root of 50. So this is where we would say that this is the square root of 25 times the square root of 2. So we break it down using the product property of radicals. Again, I need to use one of these numbers here, these perfect squares. I need to use one of those numbers. So I'm looking, can I rewrite 50 as one of those numbers times something else? The reason being the square root of 25 is 5. So I get 5 root 2. That is my square root of 50. Another example, square root of 98. What can I write 98 as a product of? 49 times 2, so I get 7 root 2. Moving on, square root of 48. I can write that as, I know this is root 4 times root 12. Well, the thing is, root 12 is not broken down completely, because I can take another root 4 out of there. So root 4 times root 3. And again, these are all multiplies. So I have 2 times 2 root 3, or I get 4 root 3. Now the thing of it is, if I recognize that I could take root 48 and write it as the square root of 16 times the square root of 3, I would get 4 root 3 in a couple steps less, but notice I get the same answer. So when breaking down radicals, as long as you're taking out a perfect square, and you keep simplifying the radical to where it no longer breaks down, you will eventually get to the right answer. You just need to do a few more steps than if you find the largest radical first. So group 125 would be root 25 times 5. So we get 5 root 5. The reason we talk about this is when we're trying to find the geometric mean, we're going to have some random numbers. So let's say we pick a random number of 3 and let's say 20. So we have the geometric mean of 3 and 20. So we're looking for x, so we have 3 and 20. We cross multiply. We get that x squared equals 60. Square root both sides. 60 is not a perfect square, so I need to break it down. Root 4 times root 15. So I get that x equals 2 root 15. One way you use proportions is estimating, or geometric means is to estimate. So it says in a forest, you can count 36 blue spruce trees in 3 acres of woodland. You notice that the woodland seems to have the trees fairly evenly distributed. Estimate how many blue spruce trees would be in the entire plot of 25 acres. So we count 36 trees in 3 acres. And so we're trying to figure out how many would be in 25 acres. The reason I put the labels on here is because I have this 25, it's easier for me to figure out where the 25 goes. Because I know trees over acres is going to be equal to the number of trees over an acre. It's simply a proportion. So this is X number of trees. And you can pick a different variable if you want a tree, T to represent tree or something like that. And then we would go about and cross multiply, so we get 3x equals, and then 36 times 25 is 900. Divide those by 3, and we would get about 300 trees. So it's just a matter of applying a proportion to a word problem. There's a set of 3 gears, but the proportion of gear 1 to gear 2 is the same as gear 2 to gear 3. The first gear has 20 teeth and the second has 30 teeth. How many teeth are on the third gear? So I know it, when I read it, it has proportion. So automatically I know fraction equals fraction. And it says proportion of gear 1 to gear 2, so this is G1 to G2, is the same as gear 2 to gear 3. So gear 2 to gear 3. That's my proportion right there. Gear 1 to gear 2 is in the same ratio as gear 2 to gear 3. And now what we're going to do is plug in numbers for the values we know. We know gear 1 is 20, so we'll put in 20 for gear 1. And the second gear, or gear 2 as we've been calling it, is 30. And we're solving for gear 3 in this case. Notice we have the geometric mean and we're solving. Now, like I mentioned earlier, in the last one, you can simplify. 20 over 30 is the same as 2/3. The reason I do this, when I go to multiply, now I only have 30 times 3, so that's 90 equals 2g. So that means there are 45 teeth. So this way, 45 equals g. So that means there are 45 teeth on gear 3. And you have solved it. It's just a matter of taking your time, thinking about what is the proportion I'm trying to solve, and then writing it out, and then plugging in the numbers versus just automatically trying to plug in and putting 20 and 30 on opposite sides and solving for the geometric mean.